Hello, everyone, and welcome back to Psych 3510. Today, we're going to be going over Chapter 9, which is Multivariate Correlational Research. At this point, we've gone over correlations and hypothesis testing with correlations. We've gone over regression and multiple regression. And Chapter 9 is sort of a chapter that bridges a gap between those two or combines those two and discusses how we use those various tools, regressions and correlations, in order to solve problems about causality, essentially, and how we attempt to assert causality with this variety of tools without using experimental designs, but when all that we can do is use correlational designs. So what we're going to do here is review the three causal criteria really quickly, and then discuss how these multivariate correlational designs can actually help us approach and approximate these causal criteria, even though we're not doing an experiment. We're going to do that with these points below about temporal precedence, ruling out third variables with internal validity, pattern and parsimony, and then a couple things that we've already seen previously, mediation and moderation. So let's quickly, again, sort of remind ourselves what we're doing here. We're looking at correlational research designs. So we're going to call them multivariate correlational designs, meaning they involve more than two variables. So three or more measured variables. And we're going to try and get as close as we can to establishing causation with a correlational design. Now, this is an important distinction because we've said earlier in the semester that the only way to establish causation is with an experiment. And an experiment is a situation in which we change something about the world, right? We manipulate something. We put people into two groups, and then we give one group the medicine and the other group gets a placebo, right? Or we put people into two groups and we make one group angry and we do nothing to the other group, and then we see what the effect of that anger is, right? The researcher takes an active role in manipulating the world. Whereas in a correlational design, what we're talking about here, the researcher is just measuring the naturally occurring behavior in the world. Now, measuring naturally occurring behavior does not allow us to assert causation, because assessing naturally occurring behavior typically does not allow us to establish temporal precedence, which is the idea that if A is going to cause B, A must precede B in time. And correlational designs typically don't allow for causation because they lack controls on internal validity. Meaning, if we claim that A causes B, is it possible that another variable C is actually doing the causing, right? If we just measure A and B, then it's always possible that C is impacting our experiment and we just don't know about it. So traditionally, we say that correlational designs cannot allow us to assert causation. Correlational designs allow for covariance, which is that variables have a relationship with one another. That's fine. We can get there with correlational studies, but they typically don't allow for temporal precedence and internal validity. However, we have some more complicated designs of multivariate correlational designs that can allow us, I'm not going to say to establish temporal precedence and internal validity, I'm going to say that allow us to approximate temporal precedence and internal validity in such a way that maybe over time, with multiple studies and multiple different types of research, we can feel comfortable asserting causation, even though we've never done an experiment. So that's what we're going to be talking about today, is how we can approximate these criteria for establishing causation, even if we don't have an experimental design. So, like we said before, experiments are best for establishing temporal precedence and controlling internal validity because they allow us to manipulate something about the world and then measure its impact. But we can't always do an experiment. And if we can't always do an experiment, how do we establish that temporal precedence and how do we control for internal validity? Because in many cases, an experiment is not possible. There are two major reasons why an experiment might not be possible. The first is that we cannot randomly assign people to our to things like their preferences. So if we say, does preferring living in the north or the south, right, cause some change in behavior or personality? Well, we can't assign people to their preferences. We can't randomly assign people to living in the north or living in the south, right? We can't ethically do that to people. So we're just left with their naturally occurring behavior. So an experiment is impossible. Another example would be smoking, right? Smoking cigarettes. It would be unethical to divide people into two groups and to force half of them to smoke a pack of cigarettes every day and the other group to not smoke a pack of cigarettes so that we can see if cigarettes cause cancer. Because we're actively doing something that's a detriment to the health of certain people, and we expect it to be a detriment to their health. So it's unethical to do an experiment on that topic. But nonetheless, we need to be able to study the effect of smoking and cigarettes. Like, that's an important thing to study. We just can't do it experimentally. So what we need to do is come up with research designs that allow us to approximate causation, that allow us to approximate internal validity and temporal precedence. And those are the designs that we're talking about today. So we need to understand that experiments are best, but experiments are not always possible. And so when experiments are not possible, we've developed some techniques that get us as close as we can get without doing an actual experiment. So one of the best things you can do to try and approximate causation in a multivariate correlational design is to look at something over time. Right? We call this a longitudinal design. So longitudinal means over time. And so what we can do is we can measure people's maybe behavior and whatever outcome we're interested in at multiple time points over time, for a month, for a year, for 10 years, whatever the scope of our project is. And looking at things over time can actually help us approximate causation through the sort of interaction of three different types of correlations: cross-sectional, which we can think of as just like a normal correlation, autocorrelations, and cross-lag correlations. So we're going to take each of these in turn. So a cross-sectional correlation is just a normal correlation where we say we're going to measure variable A, we're going to measure variable B, and we see how they correlate. So you can imagine doing this at multiple time points with the same variables. Let's talk a little bit about what this example is here. In our top row, we have variable, we'll say A, which is overvaluation. What this is referring to is a parent's tendency to essentially overvalue the accomplishments of their child. So telling their child, wow, that was so great, that was amazing, you did such a good job, you're so smart, you're brilliant, even when maybe their performance was not. So the parent here is giving unrealistically positive valuations of their child's behavior. So variable A is how much does a parent overvalue their child's behaviors. Variable B, our bottom row, is the child's narcissism. And narcissism is a personality trait that basically measures how awesome you think you are in comparison to other people. Right? So a narcissist would think that everyone else is the problem, they are amazing, right? Nothing they do can possibly be bad or wrong. And so these developmental psychologists thought, well, if mommy and daddy tell you that everything you do is amazing, if they overvalue all of your behaviors, that might lead to narcissism, right? Thinking that everything you do is amazing and that you cannot go wrong. So we can see that at 4 time points, our researchers measured overvaluation and then they measured narcissism in the child. And we can just have normal, what we call cross-sectional correlations, meaning at each time point, how much are overvaluation and narcissism correlated with each other. We can see early on, there's basically no correlation. And then we see an increase to what we might call a small correlation. 0.07 at time point 2, a slightly larger, 0.1 really 4 at time point 3, and then 0.1 at time point 4. So what this would tell us is that, maybe there's something here. Overvaluation and narcissism are like maybe kind of correlated. It's pretty small. It's pretty weak. It's not necessarily anything to like go write home about, right? There's something here, but it's not dramatic. A second kind of correlation that we can evaluate with a longitudinal research design are autocorrelations, which instead of correlating variable A with variable B at each time point, we can see how stable is each variable over time, meaning how is overvaluation at time 1 correlated with overvaluation at time 2 and time 3 and time 4, meaning if a parent is high on overvaluation at time point 1, do they stay high at time point 2 and 3 and 4? And it appears that they do, right? Parents who overvalue their children do so consistently over time because we have high positive correlations for all of our 4 time points. And the same would be true, the flip side of the coin. Parents who are low in overvaluation stay low in overvaluation, right? That's what this positive correlation means. And we can see that narcissism is fairly stable over time as well. Another large, robust correlation here across our 4 time points, meaning children who are high on narcissism at time point 1 stay high on narcissism through time point 4, and children who are low on narcissism stay relatively low on narcissism across time. So we've established with our cross-sectional correlations that maybe overvaluation and narcissism are related to each other. And we've established, at the very least, these behaviors and traits are stable over time. But the question is, how can we use this longitudinal design to ask a question like, does overvaluation cause narcissism? And think back, one of the things we have to do to establish causation is we have to establish temporal precedence, meaning that variable A occurs before variable B if it is going to cause a change in variable B. Our cross-sectional correlations don't do that, right? Overvaluation at time point 1 is occurring at the same time as narcissism time point 1, and the same time for time point 2, the same time for the comparison at time point 3 and time point 4. Right? This comparison, this cross-sectional correlation, compares variable A at the same time as variable B, or from the same time as variable B. But with this longitudinal design, we can do something really cool called a cross-lag correlation. So we can say, does parental overvaluation at time point 1, is it related to narcissism at time point 2? Because if we cross over, that's why it's called like a cross-lag correlation, then I've established temporal precedence, right? I'm using the data from overvaluation at time 1 to establish temporal precedence for narcissism at time point 2. So I know that my measurement of overvaluation does establish temporal precedence on narcissism if I cross over the correlation to the next time point. And so this has already established 2 of our 3 necessary preconditions for causation. We have covariation, right? There is a correlation here. It's not giant, but it's something. And we have established temporal precedence. So we're 2/3 of the way to causation already using this cross-lag longitudinal research design. And notice, just sort of interestingly, that narcissism is not predicting overvaluation, right? And that helps us with the directionality problem, right? Is A causing B or is B causing A? With if you just have cross-sectional correlations at the same time point, you can't tell if A is causing B or B is causing A. But here we can tell that overvaluation is impacting future narcissism, and narcissism is not impacting future overvaluation. So at every cross lag, we get the same pattern that overvaluation at time point 1 predicts narcissism at time point 2. Overvaluation at time point 2 predicts narcissism at time point 3, so on and so forth. And so because this is only happening from overvaluation to narcissism, and because it's happening at each cross lag time point, we're pretty confident that overvaluation is the causal force on narcissism, because of our establishment of covariation, temporal precedence, and we're sort of controlling for the is it A to B or B to A problem. Now, if we can establish covariation and if we can establish temporal precedence, we're left with our third criteria for causal claims. That's internal validity. And if we remember what internal validity is, it's the variable that you're claiming is doing the causing is actually doing the causing. This does not have to be the case, right? You can claim that A causes B, but like we said earlier, there's some variable C or variable D or variable E out there in the world that are actually doing the causing. You're just naive to them because you didn't measure them. So what we can do is combine maybe these research designs using longitudinal cross-lag correlations. We can throw in some multiple regression, which, as we discussed in that section, allows us to control for certain variables. Remember when we talked about stepwise multiple regression, where we put a variable in first and we let it sort of consume its piece of the regression, and then we sort of throw that away, we have controlled for the effect of that variable in a sense. And so there are a couple different ways we can do that, and so we're going to talk about them here. So first, let's talk about the sort of parameters of this example, looking at our two variables of interest. On the x-axis, we have exposure to sexual content on television. So either you're low on exposure to sexual content or you're high on exposure to sexual content based upon probably the amount of TV you watch and obviously the kind of TV you watch. People will vary on how much exposure they have to sexual content. And on the y-axis, we have risk of pregnancy. Some people will be at low risk of pregnancy based on their behaviors. Some people will be at high risk of pregnancy based on their behaviors. And if we just look at these two variables, we see a pretty solid positive correlation. We might describe this as a moderate positive correlation. This is obviously our line of best fit kind of tracks my laser pointer right here, right? That meaning the more sexual content you consume, the higher your risk of pregnancy. And the less sexual content you consume, the lower your risk of pregnancy. We can't assert causation, right? Because we don't have temporal precedence and we haven't established internal validity by controlling for other variables. But we could, right? As we discussed earlier, we could make this exposure to sexual content at time point 1, and we could make this pregnancy risk at time point 2. So we could take care of temporal precedence there. But what if we want to add a third or a fourth variable to the mix to try and quote unquote control for it? So we can sort of visualize what it looks like for something to be controlled for. And here our third variable is going to be age. We look at 16-year-olds, 18-year-olds, and 20-year-olds. Let's focus on this figure on the left over here. Obviously, every number 16, imagine that means that this data point is from a 16-year-old. Same thing for 18 and same thing for 20. And if our results were as such on the left, we would say that age does not matter for this relationship, right? Look at the pattern for the 16-year-olds, it's a positive correlation. The pattern for the 18-year-olds, it's a positive correlation. And the pattern for the 20-year-olds is a positive correlation. So by adding the third variable age, we can actually we actually get a little bit stronger in our claim about internal validity, because we can say, regardless of age, right, controlling for age, the pattern remains the same. Right? 16-year-olds are the same as 18-year-olds, are the same as 20-year-olds. So it doesn't matter what your age is. The higher your exposure to sexual content on TV, the higher your risk of pregnancy, right? The pattern is the same for the 20-year-olds, the 18-year-olds, and the 16-year-olds. They vary a little bit, but the general positive correlation pattern remains. So controlling for age, the relationship stays the same. So that makes our causal argument stronger, because we have essentially removed from consideration one of a potential confounding variable, age. On the right over here is what the scatter plot would look like if age mattered, right? Which would be a problem for our causal conclusion. So what if age has an impact on this relationship? Because we can see here, if we just look at 16-year-olds, there's like no relationship, right? We would draw a flat line. If we just looked at 18-year-olds, we would draw like a flat line. If we just look at 20-year-olds, we would draw a flat line. So what's going on here is that age is accounting for the relationship between exposure to sexual content and risk of pregnancy. Exposure to sexual content and risk of pregnancy are not actually having a causal relationship with one another. It's simply that 16-year-olds have lower risk of pregnancy, and they also happen to have lower exposure to sexual content on TV. 18-year-olds have a moderate amount of risk of pregnancy, right? They're on average higher than the 16-year-olds, and they have a moderate amount of exposure to sexual content, right? They're further to the right than the 16-year-olds. And as a group, the 20-year-olds are the highest on both. 20-year-olds are more likely to get pregnant than 16-year-olds, and 20-year-olds are more likely to be exposed to sexual content. So the relationship between exposure to sexual content and pregnancy risk is simply a function of age. Age is the variable that's actually doing the causing here. As you age, your risk of pregnancy naturally increases. As you age, your exposure to sexual content naturally increases. Exposure to sexual content and pregnancy risk do not have a causal relationship with one another. They are correlated, but these data show that after we control for age, the relationship between pregnancy risk and sexual content disappears, right? If we factor in age, then this original relationship goes away. And what's actually important is the variable of age. So we can use this sort of multiple regression framework to ask multiple questions at the same time, because maybe we think that age and exposure to sexual content on TV have a relationship with pregnancy risk. And so, and we saw this in our previous examples from the multiple regression lecture, that we can get a sort of model, right, that incorporates both of these variables together. And we can actually assess, okay, is exposure to sex on TV significant? Let's just say yes. But hey, also age is a significant predictor, right? And its beta is larger than exposure to sex on TV. So age might actually be more important. So we want to think about speaking about these multiple regressions in terms of the criterion variable, which is our outcome, our dependent variable, and the predictor variables, which are our independent variables that we predict are quote unquote doing the causing. So here we have predictors, exposure to sex and age, and our outcome criterion, pregnancy risk. So when we have a statistically significant beta, we can attempt to describe those effects as such. The relationship between exposure to sex on TV and pregnancy is positive, even when age is controlled for, right? Because age is in the model, right? So age is taking up some of that variance, that variability. And even with age in the model, exposure still remains significant. That's possible. We could say the relationship between exposure to sex on TV and pregnancy is possible even when age is controlled for. And the relationship between exposure to sex on TV and pregnancy is positive and is not attributable to the third variable of age because it holds even when age is held constant. So even when we include age in the model, exposure to sex on TV still matters. Age matters too, right? That this predictor is still significant as well. You can have multiple significant predictors in the same model. And so we can maybe a more complete claim, sorry about that. Maybe a more complete claim would be something like um, age is a significant predictor of risk of pregnancy. Even when controlling for age, exposure to sex on TV still remains a significant predictor. So, in essence, we have built a more complex model where they are both predictors of pregnancy risk. This is helping us with internal validity, right? Because we are now understanding the more complex nature of how these variables are relating to one another and which variables are related to changes in the other variables. So we're not left with sort of blind to the effect of age. We now understand the effect of age. And so that is going to allow us to approach causation in a greater fashion. What if we weren't significant? So here our example is we're predicting academic success from parental involvement and frequency of family meals. And we could say when something is not significant, this is kind of what it sounds like. The relationship between family meal frequency, that's our first predictor, and child academic success, that's our criterion, our dependent variable, is not significant when we control for parental involvement, meaning that parental involvement is what matters. Parental involvement is the significant predictor. How often you have meals as a family is no longer important if we include parental involvement. Another way to look at this is that frequency of family meals essentially measures the same thing as parental involvement. These are basically the same variable. So when we put one of them in and it gets to take some of the variance, there's nothing left over for the other variable because they quantify the same things. Meaning parents who are more involved have families in which the frequency of family meals is high. So if we have two variables in a model and one of them is significant, what that means is that when controlling for the significant one, the thing that we thought might be related, frequency of family meals, goes away. It's no longer needed. So we can say that again in a couple ways. The relationship between family meal frequency and child academic success can be explained by the third variable, parental involvement, right? We thought frequency of meals would predict success. Turns out it doesn't. Really, what matters is just parental involvement. And again, this is fine. We are coming to a more complex and nuanced and better understanding of how these variables relate to each other. We're doing it in a way that involves multiple correlational relationships. And of course, there's not technically a limit to the number of variables that you can have in your study. So let's go back to our original example of risk of pregnancy. So that's our criterion. We can think of a ton of variables that can impact risk of pregnancy. Exposure to sex was our original one. We could think of total television exposure, right? Not just sex on TV, but just how much TV do you watch in general? Age, grades, parental education, race, so on and so forth, right? History of deviant behaviors. And so we can throw all of these into the model together, and we can see which ones are judged by the model as being unrelated to pregnancy risk, and which ones are related. And in fact, this is actually from a research study in 2008. We find a very complex relationship. So exposure to TV, total television exposure, and age all predict risk of pregnancy, as do being Black, being female, living in a two-parent household is a negative predictor, and your history of deviant behavior is a positive predictor. So what this tells us, and let's keep in mind the signs here, that the greater your exposure to sex on TV, the greater your risk of pregnancy. The greater your exposure to television in total, the lower your risk of pregnancy, interestingly, right? That's a negative relationship. So the more TV you watch, the lower your risk of pregnancy. Age is a positive predictor. The older you get, the higher your risk of pregnancy. That makes sense. Being Black is a predictor of pregnancy, as is being female. That makes perfect sense. Living in a two-parent household is a negative predictor of pregnancy risk, meaning that if you live in a two-parent household, you are less likely to get pregnant. And history of deviant behavior is a positive predictor, meaning the more that you've skipped school, stolen, cheated on a test, et cetera, the greater your risk of pregnancy. So suddenly we get this multifaceted, complex architecture of a predictive model that can help us explain risk of pregnancy. And with the inclusion of all of these variables, we are essentially removing issues of internal validity, right? Because remember, internal validity is all about, are the things you think doing the causing actually doing the causing? And here we have a whole bunch of variables that might be relevant, and we can just lay it on the table and say, look, we asked questions about all of these potential confounding variables, and these were the ones that were significant, and these were the ones that weren't, right? So you're, in essence, controlling for those threats to internal validity. So you'll hear these particular phrases a lot, maybe in the popular press and news articles. And we want to look for some key terms when we're reading these things to try and interpret them, such as controlled for, taking into account, correcting for, adjusting for. These are often indicators of a multivariate correlational or multivariate regression analysis, because that's what those analyses do. They take into account, they adjust for, they control for. So the problem is that even though we can hope to approach causation, they do not in any sense, establish causation. They're not foolproof. Any one given study can have problems with internal validity, for example. So we don't want to go as far as to say, listen, I did a longitudinal study. I have covariance. I established temporal precedence. I put a bunch of variables in the model, so I'm helping control for internal validity. Poof, I have established causation. Like we said, an experiment is the only way to establish causation. I would prefer to say that we might approach causation with a well-designed multivariate longitudinal regression analysis. So we want to always keep in mind, even though we're talking about these things in terms of causal variables, a correlational design can never establish causation. However, we can get even closer to causation by using principles known as pattern and parsimony. Pattern is going to refer to having a consistent pattern of results over time from different studies, from different labs, maybe different parts of the world. A pattern of, in this case, 5 different studies that all point towards the same conclusion. So if we have a pattern of studies, then that boosts our confidence towards causation even more. For example, here, in study 1, it was found that the longer a person smokes cigarettes, the greater their chances of getting cancer. Right? It's not an experiment. In and of itself, it does not establish causation. It shows a relationship between smoking cigarettes and cancer. Study number 2 then finds people who stop smoking reduce their rates of cancer versus people who continued smoking. Again, we can't do an experiment here because we can't force people to smoke or not to smoke, but we find this sort of reciprocal relationship in study 2, that if you quit smoking, your rate of cancer goes down. Study number 3 finds that if you're a smoker, you tend to have a particular type of cancer in your lungs. Right? You don't get prostate cancer from smoking. You don't get brain cancer from smoking. You get lung cancer from smoking. And everyone's getting the same type of cancer who smokes. Study number 4 finds that people that smoked filtered cigarettes have a slightly lower rate of cancer than people who smoke unfiltered cigarettes. And study number 5 finds that people who don't smoke but live with smokers have higher rates of cancer too. So here we have 5 independent studies. These could be done by different researchers at different labs across the world that all point to a pattern of causality, which is that smoking cigarettes causes lung cancer. Let's note that any one given study does not establish causation, and we would not want to claim causation from any one of these studies in particular. But taken together, we start to really see a pattern of results that closely approximates causation. Parsimony is the idea that science wants to offer the simplest, most correct explanation of a phenomenon. So we simultaneously want to be as correct as possible, but as simple, as parsimonious as possible. And so when we take into account these 2 factors, pattern and parsimony, and we apply them to these 5 independent findings, it leads us to the conclusion that cigarettes cause cancer, even though one particular study cannot assert causation. The pattern of results, combined with our need to be as simple and direct and clear and correct as possible, parsimony, leads us to the conclusion that we should claim cigarettes cause cancer. So we have lots of steps that we have to take in order to get to causation from a multivariate regression or correlation based study. We have to do that single study extremely well, and even then we cannot assert causation. We have to have a pattern over time, different labs, various types of studies, looking at different variables, but they're all related to one another that show this same pattern of results. And then we come to the most parsimonious conclusion, which is cigarettes cause lung cancer. Another very important and very relevant and great example of pattern and parsimony is climate change, right? No one single study can ever prove that climate change is happening. That's impossible. However, if we look at the pattern of results from geology and biology and physics and chemistry and environmental studies, and if we look at mammals and insects and rainfall and weather patterns and hurricanes, and we can look at a pattern of results across 10 different disciplines over time, with 98% of the studies pointing in the same direction. And we can step back and say there is a pattern here that climate change is happening. The most parsimonious explanation is that the burning of fossil fuels by humans is accelerating the rate of climate change. That's another fabulous example, in addition to cigarettes causing lung cancer, where we can take these non-causal studies, build a pattern, a relationship with them, and then come to a parsimonious conclusion, all the while keeping in mind that no single study actually gets to claim causation. This is often difficult to present in the popular press. Journalists and in the era of television news and trying to get ratings and clicks and views and ad money, sometimes journalists, whether intentionally or unintentionally, will not represent this in a fair way. They might selectively report on a single study, and they won't report this broader scientific process of causation, not causation, pattern, parsimony, right? All of these really complex details we've gone into, because complex details are complex. People don't like them. People just want the soundbite. They want the headline, and the headline is sexy. Understanding this back and forth between experiments, correlational research, longitudinal research, pattern and parsimony, covariance, temporal precedence, internal validity is really, really, really difficult to understand. And so it doesn't always get represented fairly. So we want to be careful when we hear a report about a single study, right? One study is very unlikely to tell us anything super important. Especially if it's a correlational design. If it's an experimental design, we give it a little more credence, right? We give it a little more weight. But if it's a single study that's a correlational design, we might want to hold out until we have pattern and parsimony before we make broad conclusions that approach causation. Okay, we're going to quickly return to our idea of mediators versus moderators. We've discussed them before, but they work well here because mediators and moderators are another set of tools that we can use in a correlational research design in order to help establish these things like temporal precedence and internal validity. So we first want to discuss the difference between a mediator and a third variable. So mediators are variables that are going to explain the relationship between two other variables. Third variables are variables that sort of are external to our correlation, have nothing to do or have very little to do with our two variables, and are problematic for causal claims. So both mediators and third variables can be involved in multivariate research. They can be detected using multiple regressions. Third variables are external to our correlation. They're problematic, whereas mediators are internal to our causal variables. They're not problematic. So we're gonna see what that means here. So, for example, if we want to understand the relationship between the amount of deep talk, so complex, meaningful conversations you have, is deep talk related to your well-being? So we find that the more deep talk you have with other people, the better you're doing as a person. Right? Your psychological well-being is more healthy. When we add in the mediator of social ties, we find that what's actually happening is that people who have a lot of deep talk in their life, a lot of meaningful conversations, are just people that have more friends and have better friends and have higher quality social relationships. And those high quality social relationships are actually what's responsible for your well being. So, deep talk isn't causing well being. Deep talk is just a function of having quality social relationships. Quality social relationships is what's actually causing your well being to increase or decrease. Over here in this figure on the right, education is an external third variable that would be a problem for our internal validity or our causal claim about deep talk and well being. What we might find is that people who have a higher level of education engage in more deep talk, and people who have a higher level of education are better off. They have higher well being. So it's not that deep talk has anything to do with well being, it's that deep talk and well being just happen to both be related to education level. So if this is the situation, then we have education level as a third variable. We might call it a confounding variable. And it's what's actually responsible for this relationship, which doesn't actually exist, right? The relationship between deep talk and well being is just a figment of statistics. Deep talk in reality has nothing to do with well being. They just both happen to be related to level of education. In our mediation example, deep talk does matter, right? Deep talk matters. It's just that deep talk is really a function of a larger variable, which is social ties. And social ties is doing the work, right? Social ties means that you have more deep talk. Social ties means that maybe there are people there who can help you in a hard time. Social ties mean that if you lost your job, maybe there's someone you could move in with for a month or two, right? And so social ties is what is enabling your well-being. Deep talk is just a piece of the social ties puzzle. So social ties is actually internal to this relationship. And so this gives us a really good understanding of what's causing what. This relationship is a third variable, which means that deep talk and well-being have nothing to do with each other. Their supposed relationship is just a figment of the fact that they're both related to education. Now we want to compare and contrast mediators with moderators. So both mediators and moderators are types of variables that help us understand causal claims and internal validity. We're going to repeat this sort of mantra over and over again here. Mediators ask why, moderators ask for whom or when. Mediators ask why, moderators ask for whom and when. So let's go back to our example. This relationship between deep talk, social ties, and well-being is a mediation. So why is deep talk related to well-being? Because deep talk is a function of quality social ties. So I'll repeat that again using our keyword why. So this mediator, social ties, answers the question, why is deep talk related to well-being? Because it's a function of social ties. That's why. Education level is a moderator because it says for whom or when, meaning the relationship between deep talk and well-being changes depending upon your level of education, or depends upon your level of education, right? Maybe when people are highly educated, both deep talk and well-being increase. When people have low levels of education, deep talk and well-being decrease. This moderator, education level, is answering the question, for whom or when is this relationship available? So here is a nice figure that we're going to break down to end this lecture that that illustrates the difference between mediation, moderation, and third variables. So mediation, again, why are two variables related? A is related to B because A leads to C and C leads to B, right? Or A is a function of C and C is causing B. So an example here would be, does viewing violent television, right? That's A, that's our orange box. Does viewing violent television, is it related to aggressive behavior? And it's because viewing violent television causes you to become desensitized to violence, right? Possibly. Right? Why is viewing violent television related to aggression? Because of desensitization, right? Desensitization is doing the work. Viewing violent TV is causing you to become desensitized, then becoming desensitized is causing you to aggress. That's a possible relationship between these variables. It's also possible that there's a moderator that moderates the relationship between viewing TV and aggression. So we say viewing violent television, A, is related to aggressive behavior, B, but it depends upon the type of person you are, right? For variable C type 1, the relationship differs from variable C type 2. So maybe variable C is parenting behaviors, right? So for children whose parents discuss the television content with their children, the relationship is not significant. It's a very small correlation. But for children whose parents do not discuss the content of the television with them, we see a significant positive relationship. So the relationship between viewing violent television and aggressive behavior differs based upon the type of parents you have or the parenting behavior present. Parenting behavior, in this case, would be said to moderate the relationship between viewing TV and aggressive behavior. And lastly, it could be the case that viewing violent TV and aggressive behavior are not related to one another at all. They are simply related to a third variable, which could be having lenient parents. So having lenient parents is related to viewing violent television. Having lenient parents is related to aggressive behavior, and viewing violent television has nothing to do with aggressive behaviors. That would be a third variable. All right. So we've discussed these multivariate designs. We've discussed our 4 validities previously, right? We've talked about construct, external, and statistical validity. And so when we include this internal validity discussion, as we have today, with multivariate, longitudinal, mediator, moderator, regression, correlational designs, plus pattern and parsimony, we can establish all of these validities potentially. And as we said before, we can't with any one study claim causation, but we can approximate or approach causal claims, particularly when we have large bodies of work and patterns of behavior or patterns of results. So that's it for multivariate correlational research. This is a complicated lecture. If you need to watch this again, I highly recommend doing so because there's a lot of moving parts here. We're sort of combining a lot of different things that we've discussed previously. But this is a really important thing to understand because experiments are not always possible. We can't always do experiments because of constraints on ethics, because of constraints on our ability to randomly assign people, and because of just practical concerns like time and money and work effort and things like that. So we often need to approach or approximate causation using these correlational methods. It gets really complicated, as you've seen, but those complicated designs and those complicated conclusions are the way in which we do our very best to get to that sort of holy grail of research, which is a causal claim. So, thanks everybody for watching, and I will see you next time.